In the previous section, we looked at the tangent function. In this section, we're going to look specifically at the cotangent function and the graph of it. Now, very similar. And by the way, the cotangent and tangent functions are going to look pretty close to one another. They're going to share a lot of the same sorts of steps and properties, but there is going to be difference between those graphs. Remember that the cotangent function can be written as the ratio of cosine to sine. Okay, so there are going to be some parts where the sine function is equal to 0, which means that the cotangent function would be undefined there. All right. Now, basically remember that the cotangent function is x over y. And so whenever the y function is equal to 0, that means that we're going to have an undefined cotangent graph and a vertical asymptote there, right? So that occurs when theta is equal to 0, pi, 2 pi, etc. And if we go back to our graph, remember, we're looking for where the x coordinate is 0, okay? So we have, or the y coordinate is 0. So that's right here, it's right here. And then if we went around once, that would be 2 pi. If we went around and then terminated here, that would be 3 pi, etc. Okay, so that's how we get the asymptotes to be 0, pi, 2 pi. And of course, there's coterminal angles, like we said. And so the equation for the asymptotes for the cotangent graph is going to be pi n, where n is an element of the integers. All right. This is the way that we're going to write it. Okay, so pi n, x is in the integers. Okay, so remember, z is the symbol for the set of integers. Similar to what we did in the graph of the tangent function, let's now plot the cotangent function. So we know that right here at 0 and pi, we know that the function is undefined. Okay, and also at 2 pi and 3 pi and 99 pi and 250,000 pi, etc. Okay, so right here it's undefined, and then down here it's undefined. Right? Now, if we want to try to find some of the values of the cotangent function, we could just go in the unit circle to find some of them, okay? And I'll go ahead and find a few of them for you, okay? And then the other ones, I'll just assume that if I find a few of those, you could go through in the unit circle and find them for yourselves, okay? So let's look at the cotangent of pi 6, okay? So cotangent of pi 6. Now remember, the cotangent is x over y. And so at pi 6, the x coordinate is going to be root 3 over 2, and the y coordinate is 1/2. So it'll be root 3 over 2 divided by 1/2, which will be root 3 over 2 times 2 over 1, which is going to be the square root of 3. And I believe that we showed that the square root of 3 was like 1.73 when we were looking at the tangent function. Okay, so right here we get the square root of 3, or that's the same thing as approximately 1.73. All right. So at pi fourths, okay, that one's going to be the easiest one, is pi fourths. What's going to happen is that we're going to end up with a 1 because we end up with root 2 over 2 divided by root 2 over 2. All right, so right here, the cotangent of pi fourths is root 2 over 2 divided by root 2 over 2, which is 1. All right, and so we could follow that in suit. Okay, so right here, this would be root 3 over 3, which I believe we said was 0.58 from one of our previous videos. Let's just verify that. So we have square root of 3 divided by 3. That's going to be 0.58, okay? And then at pi halves, it's 0. And then here we have negative root 3 over 3, which is going to be negative 0.58. And then at 3 pi fourths, we have a negative 1. And then right here, we have a negative root 3, which is approximately negative 1.73. All right, so if I was to graph this tangent function just by using this table of values, we have an asymptote at x equals 0. Okay, so x equals 0 and x equal pi are going to be the asymptotes. So right here, right on the y-axis is going to be an asymptote. And then right about here, we're going to have an asymptote as well. All right, so again, forgive my inability to construct these all that well. All right, so just assume that that's pi. All right, now if I plot these points, 0.5, 2, and then 1.73. All right, so somewhere like up here. All right, I know it's not that great, but could be worse. All right, so maybe right about here. Right. And then we know pi halves is 1.570. I know I skipped the other one. So 0.79 and positive 1, maybe like right about here. All right. And then from there, we have negative zero point 0.5 or 2.09 and then negative 0.58. So maybe like somewhere down here. Okay. And then 2.36 and then negative 1. All right, so somewhere down here. All right. And then finally, we have 2.62, and then somewhere down here is going to be that 1.73, so something like this, okay? And so our cotangent function is going to look something like this, okay? And of course, I missed one of the points. I'm sorry about that, but let's just blow it up and pretend it's just a really big point that passes through there, as with this one, okay? All right, now that's about what our cotangent function looks like, okay? If we go through, though, and we take a look at what Desmos suggests, now remember, this is periodic, so there's going to be another cycle, maybe over here, that has the exact same properties, okay? So if I was to graph it, and it should be the same length, and I apologize, it's not, okay? But that would be another one of the asymptotes, and that's what it would look like, okay? So if we go to Desmos, and we type in y equals cotangent of x, okay? And I'm going to zoom back in. I think I had zoomed out from a previous problem, all right? And of course, we could plot those asymptotes. Remember, we had one was x equals 0. We had another one was x equal pi, right? And so that's exactly what we plotted, okay? So from here to here, all right? And just to check, remember we had the point like pi 6 square root of 3. All right, so that point should be on the function somewhere, right? And it looks precisely like it's on the function. I think we had another point like pi halves 0. All right, so pi halves comma 0. Let's see if that ends up on the function. Hey, there it is. Not surprising. Okay, so that's how we go through and plot our tangent function. And again, there are multiple infinite number of cycles of this thing. Okay, so remember, another asymptote would be if I added pi to that, because remember, the asymptotes occur at instances of pi for the cotangent function. Then here's one, okay? Here's another one over here. So we just keep getting all these asymptotes, okay? All right, so just like we did in the previous section for the tangent function, what we're going to do for the cotangent function is we are going to be able to try to graph these a little bit by hand, okay? So we're going to find the asymptotes and then use the asymptotes to guide what the function looks like.